Okay. So, Bismillahirrahmanirrahim. Today we are going to talk about the electromagnet. Okay, that is in your page number 343. So, everyone, please come to page number 343, and at the bottom of the page, you will notice the topic of electromagnet. We already discussed about solenoid. The next topic we have is electromagnet. So, what is it actually? Let us take a look. I am reading the lines of the books and accordingly I will explain it using the figure. Okay. A more powerful magnetic field can be created if a piece of iron is inserted inside a solenoid than the magnetic field that can be produced by using current only. Now, what is the meaning of this? We already saw that if I, in case of making a solenoid, okay, or through a conductor, whenever I'm flowing a current, a magnetic field is generated. Okay. So whenever only I am passing the current, the magnetic field will be generated. This is one magnetic field. Now let us think the solenoid. Inside the solenoid, okay, I have entered iron. Okay, inside the solenoid, inside the coiling, I have entered the iron piece. Now the magnetic field that is created will be much more stronger than the previous one. Okay, previously there was no iron piece or any cobalt or nickel piece was used. Only the coiling was there, coiling of the wire was there, and due to the current flow, the magnetic field was generated. But now we have inserted an iron piece inside the solenoid, and we will notice a remarkable increase in the magnetic field of the uh, magnet that will
Solenoid.
be created. Okay, so see, yes, solenoid. So this is the first line's meaning. Okay, I will read again. See, a more powerful magnetic field can be created if a piece of iron is inserted inside a solenoid. Then the magnetic field that can be created by using current only. Okay, only current, magnetic field will be a little bit weak. But if you insert iron inside the solenoid, then what will happen? The magnetic field will be stronger. The three metals, iron, cobalt, nickel, have special magnetic properties. We know that these three are magnetic substances, and these three have special magnetic properties which other substances do not. Okay. Now, what is this special magnetic properties? These metallic pieces can be considered as an accumulation of individual tiny magnets, which I have shown here. This is, you can consider this one to be an iron piece. Okay, the total one is an iron piece. What is considered is that inside there are small pieces of magnet, small pieces of magnet, but they are not in a arranged or organized way. They are scattered. Okay, so that is why in normal condition it does not show any magnetic effect. Okay, in normal condition, this is the situation how it is. If you want to take a proper look at the book 344 page, this is the figure. Okay, see, they are in unorganized way. Okay, so that is why they do not show any, they do not apply any magnetic force on any other object when it is outside the solenoid. Okay, now what changes when we insert it inside a solenoid, we will see. So these metallic pieces can be considered as an accumulation of individual tiny magnets which generally don't act as a magnet as they are aligned in different direction. These are not properly aligned. See, one is in the upward direction, okay, so not properly aligned. These substances consist of an enormous number of small magnets. See, I have shown only a couple of them, but there are enormous number of it. Okay, that are randomly oriented. Randomly means not properly arranged. Since the small magnets are randomly oriented, the piece of iron does not act as a magnet. That means if you bring any other magnetic substance near to it, it will not exert any force. That means it is not showing any magnetic property now. But when this piece is kept inside a solenoid or a coil, like I have done in the second picture, I have entered this piece inside a solenoid. Okay, so what will happen now? If current is passed through the solenoid, I am passing the current. The current is entering, it is passing through the solenoid, and it is going out from here. So what will happen? Then the magnetic field produced by that current aligns the individual tiny magnets. Now we know that whenever we will pass current through any conductor, what will happen? Magnetic field will be created. That magnetic field will be affecting the inside tiny magnets. Okay, and it will make them aligned. Okay, This is what is happening here. Then the magnetic field produced by that current, produced due to the flow of this current, aligns the individual tiny magnets. Aligns the individual tiny magnets. See, they were not aligned before, but now they are forming some kind of line. So they will be aligned. Now, as a result, what will happen? We will have a definite north pole and we will have a definite south pole. See, here north pole, south pole, not arranged, but here all the north pole are in one side and all the south pole are in another side. Okay, so clear. Therefore, the magnetic field produced by the current and the magnetic field produced by the iron piece. See, the iron has become a magnet itself now. Okay, previously it was randomly arranged, so no magnetic field was there. It did not have any magnetic effect. But now, as all the tiny magnets inside the iron piece has been aligned, what will happen? Now it will gain a magnetic effect. Okay, so if you this is actually what is electromagnet. Okay, you will see. Therefore, the magnetic field produced by the current, two magnetic field will combine now. One magnetic field that has been produced due to the flow of current, another magnetic field will be produced by the iron piece itself. Why the iron piece will have some magnetic effect now? Because all the tiny magnets are aligned now. Okay, I hope this is clear. So, and the magnetic field produced by the iron piece itself combine to produce a strong magnetic field. Okay, two magnetic fields, they will combine now and they will produce a stronger magnetic field. The interesting point is, as the current is stopped, the small magnets present within the iron piece become randomly oriented again. Okay, now you keep it inserted here, but you turned off the current. Now no current is flowing. So what will happen? The magnetic field which was affecting the tiny magnets will be gone. So there will be no more effect on this tiny magnet. So as a result, they will go back to the random orientation again. Okay, and as they are going back to the random orientation, the magnetic property that was gained by the iron will be lost. Correct. So both the magnetic property will be gone now. Acha. So the small magnets present within the iron piece become randomly oriented again and the entire magnetic field will disappear. Okay. So a magnet prepared by this process is called electromagnet. We are using electricity to produce a magnet, even though this is not an actual magnet. Okay. Actual magnet is which one? এটা আমার ডাস্টার আছে, ডাস্টারের পিছনে যেটা সেটা হচ্ছে একটা অ্যাকচুয়াল ম্যাগনেট। কেন? এই জন্য। ঠিক আছে? যাই হোক, তো এটা হচ্ছে একটা অ্যাকচুয়াল ম্যাগনেট। এখানে তুমি কোনো কারেন্ট দিতে হবে না, এটা অটোমেটিক্যালি একটা ম্যাগনেট। বাট একটা আয়রন পিস, এটাকে তুমি একটা সলিনয়েডের মাঝখানে ঢোকাও এবং কারেন্ট ফ্লো করো, আয়রনটা নিজে একটা ম্যাগনেটে পরিণত হবে। ঠিক আছে? তো ইলেকট্রিসিটি ইউজ করে আমরা একটা আয়রন পিস বা কোবাল্ট অথবা নিকেল করলেও হবে, এটা একটা ম্যাগনেটে আমরা কনভার্ট করতেছি ইলেকট্রিসিটি ইউজ করে। দ্যাট ইজ ওয়াই ইট ইজ কল্ড আ ইলেক্ট্রোম্যাগনেট। Okay, now uses of electromagnets are endless, definitely, such as in the sound we hear in speakers and earphones. Okay, in your earphone there are magnets. Okay, and in the speaker also small magnets are used. If you open it up, you will see here, according to the vibration and intensity of sound, the current is sent. The current produces an electromagnet according to the vibration and intensity of the sound. The electromagnet vibrates the diaphragm and produces the sound. We know that for the sound to be produced, there must be some vibration. If there is no vibration, no sound will be produced. Okay. Acha. So the next topic is effect of magnet on a current carrying wire. Inshallah, we will take a look at this topic, but before that, I will teach you another topic, that is electromagnetic induction. And we will talk about two experiments that has been conducted by the Faraday. Okay, so we will talk about that first, then we will see the effect of magnet on a current carrying wire. Due to this effect, two working principles we will go through. One is of motor, another one is of generator. Okay, so generator and motor we will study about this working principle of that inshallah in future classes. Today we will finish it here inshallah. Okay, so we will discuss about the mentioned topic in the next class, so do join in time. And as I took our class a little bit later, I hope I did not cause any kind of inconvenience to anyone. Okay, I ask for forgiveness if I have caused any kind of problem to anyone. Thank you very much.
No, sir. No.
No, sir. It's okay, sir.
Okay. So see you in the next class, inshallah. Till then, stay safe, stay well, and please remind me about the assignment. Okay. I will post
Okay,
it
sir.
in the group.
So you are posting in Google Classroom?
Google Classroom. Yes. Okay.
Okay, Assalamu alaikum.